Yes, good morning everyone. Welcome back to the class of maths, and here we will be discussing about a new topic, that is reflection symmetry. In the previous two videos, in the very first video we have discussed about the symmetry, and in the second video we have discussed how the pictures or the figures are symmetrical about a line or the line of symmetry. Okay, so when we were talking about the symmetrical phenomena about a line, so that was regarding, or that was considered as a linear symmetry, because there we were comparing, or we were proving the symmetrical of the two figures about a line, either it was vertical or a horizontal or a slant line. Okay, so it was considered as a linear symmetry when we were talking about the symmetrical of the two figures about a line. Here we will be discussing about the reflection symmetry, and we know reflection is the phenomena which is caused especially by a mirror. So here in reflection symmetry, what we will try to understand, that if an object is kept in front of a figure, how the image of this object or how the image of that object is formed behind the mirror. Okay, already in chapter of physics, or in the many new phenomena or the new topics of reflection, we have already learned about how the image is formed in the phenomena of reflection in the mirror. So that is somehow relatable to this topic as well. So here we have reflection symmetry, and here we will be discussing that if an object is kept in front of the mirror, how the image is formed, and what we will be getting is that the image which is formed in the mirror is exactly same as the object. Okay, as for a normal example, I can say that when we look our face in the mirror, what we see exactly the same face in the form of an image. It's not like that the face is looking a bit bigger or smaller than the actual one or than the actual face. Okay, so what we find is whatever is the dimension of our shape or of our face, of our body, the same dimension the mirror also produces in the form of the image. So that is known as reflection symmetry. Yes, one thing there is to notice that the image which is formed in the mirror possesses a lateral inversion. Lateral inversion means the left side of the object becomes the right side of the image and vice versa. Okay, so here let us have a mirror. Alright, let us have a mirror, and here what we consider is that M is an object. Okay, M is an object. Now, if I place the mirror in front of the M, what we found? We found the image here. This is the image of this object M. So, this is object, okay, and this is its image. Alright. Now, can you see the image which is formed in the mirror of alphabet M is exactly same as that of the original M? So, what we can say here is, we can say that line symmetry, that when we were folding the objects about a line, and the mirror reflection, okay, are naturally related and linked to each other. That means there also, when we were folding about a line, there also we were getting exactly the two parts identical, and here also when it is reflected about a point, this is the point about which it is reflected, this black color dash line. So this is a mirror line about which we are getting the symmetrical part of the image and the object. So we can say that this is the object, this is the image, and they both are identical. How it is? जब अगर हम इन दोनों को ऐसे fold करेंगे, when we will fold the two alphabets, we will find that they are identical or symmetrical. Alright. So here few more examples are there just to make you understand how the figure is possessing a reflection symmetry. Here it is the object. Okay, this is the mirror about which the reflection has to be seen, and this is the image. Can you see, if we overlap each other, this will be identical, or this will completely coincide each other. So the reflection is given on this side, and the point or the line or the mirror about which a reflection or the image is formed, this is known as mirror line. Alright, so few more examples. Let us say we have the emoji, okay, the reflection of an emoji. Can you see it? It is symmetrical, okay. and then a letter F. If this is a mirror line, or let us say mirror line or a mirror, if a mirror is placed in front of this letter F, the image will be formed in such a way. Okay, and this phenomena is known as lateral inversion. If I say this is the left side, for example, if I say this is the left side, alright, try to understand. If I say this is the left side and this is the right side, alright, so can you see the left side becomes the right side now, and the right side becomes the left side now. So this phenomena is only known as lateral inversion. Alright. So what we can say here is, here we see that the object and its image are equidistant from the mirror. Okay. So if I say that this is the mirror, if I say that this is the mirror, so what we can say, if I say this is the mirror, so what we can say, the distance of this object from the mirror, if I say this is x, the same distance will be of the image from the mirror. Okay, so that means they both are equidistant. Okay, next is the line joining the object and its image is perpendicular to the mirror line. So this line which is joining the object to the mirror is perpendicular to this mirror line. So can you see the angle made between them is of 90 degrees. Alright, then same, we can have the reflection symmetry of letter alphabet B. Okay, and the line about which there is a reflection, it is known as mirror line. It's the mirror image. Okay, and it's the object before the reflection, it's the image after the reflection. Alright, now here are some of the natural examples which is given. Okay, can you see of the cloud, mountains, okay, and then the forest or the mountains, and then this. So these all the figures are showing the reflection symmetry about a line. And can you see that now here one point to be understand is, can you see there is no such mirror, but can you see there is a water? This is the line which is separating the upper part to the lower part. Here it is a water. So water is acting as a mirror, and inside the water you will find the reflected image of the object. If I say this all, the plateaus and the mountains, this all is the object. So water, so this line of the water is acting as a mirror line now, and from this line we will find the image of this object. See, this object, and this is the image inside the water. Okay, so water also behaves as a mirror now, and this is the line of symmetry. Alright, and this example can be seen everywhere. Where we have a river or a pond, we can see this. Alright, then here is an activity. Okay, so it is telling that it is a mirror line. Alright, and we have figure A, B, C. So we will get the mirror image like this. Okay, after the reflection. So about this, there is a reflection. About this, it is symmetrical. So we will say it is a mirror line, and we can see now the AB is this side, BC straight, and the slant line. Okay, so since the sides are equal, since the dimensions are equal of the object and the image, so we can say that they are identical or they are symmetrical. Okay, and further more activities are there. Okay, so here this is the mirror line for the J, this is the mirror line for this rectangle, and this is the mirror line for this rectangle. Okay, so here what we are going to see, we are going to find out the answer something like, the image of this object will be something like this, about this line, J about this line, and the square. Let me show it again. Okay, see, rectangle B1, J alphabet, and this square. So somehow it is making a figure like E. Okay, so here is the reflection of a point. Now let us say we have a point. Okay, and we are talking here, A is the object of a point, it is a mirror, and here A dash is the image. Again what we are finding is that the distance of A dash from the O is same as the distance of A from point O. Okay, so this is the property when any image is formed in the mirror, they are at the equal distance from the mirror. Okay, that means the object is at the same distance from the mirror as the image from the mirror. Okay, alright, so here we have again the same what we have already discussed. It is okay, so here are some more examples to explain you how the figure is symmetrical. Okay, how the figure is symmetrical. So here is the solution. Alright, so this is the object, how the solution is formed. Let us get it reflected about this line. So this is, then this object, this image will act as object, then here, then this will give a reflection to this way. What happened in this is, let me tell you, what happened here is, this was the original object. It produces the image to this side. Now this image will act as an object for this mirror and it will produce the image to the other side. Now this image will produce the other image about this mirror here. Okay, so at all the four sides we got the reflection or the image through the process of reflection. Alright, so here the application of a reflection symmetry we can see. Okay, Sam wants to park his cycle at some point P on the road and deliver the newspaper to the house A and B. Where should he park the cycle on the road so that his walking distance AP plus BP will be least? Okay, so this is the question. So if I say this, consider it as a mirror line. So the reflection of A will be here somehow, A dash. The reflection of B will be here somehow, B dash. Okay, and we have to find the least distance. So least distance can be something like this. If this is the point P, so AP dash plus BP dash. In this way, he can deliver. Okay, or now earlier I said कि यहाँ से he is delivering the newspaper, so he has to travel this distance till here, then from there to there. So it seems to be the least distance than this whole. Alright, then let us go with the summary that all the review what we have discussed is, if a line divides a given figure into two identical halves, then the given figure is symmetrical. Obviously, if they are identical about a line, so they are symmetrical about a line, and the line is known as line of symmetry. The line symmetry and the mirror reflection are naturally related and linked to each other, because in both the cases we get the identical figure. Alright. A figure may have no line of symmetry, only one line of symmetry, two lines of symmetry, or multiple line of symmetry. It's not mandatory that a figure will always have a line of symmetry. It may have one, it may have two, or it may have infinite. Okay, like for a scalene triangle, the triangle in which no sides are equal, we have zero line of symmetry. For a kite, it is one. For a rhombus, we can say for a like kite is one of the example for the rhombus. Okay, rhombus we have two, equilateral triangle we have three, and so on. When a point is being reflected on a line, then the line acts as a mirror and the image of the point is obtained at the same distance. Okay, the line is called the axis of symmetry or the line of reflection. This we have already discussed. Okay, so this was the summary which we have discussed. Okay, so in our next class, we will have a recap of the given topics which we have discussed plus one more topic, that is rotational symmetry. I hope you understood the video. Thank you.